We started construction in August of '98 and completed it in 2000, so it's a 2-year construction. It was built to be energy efficient. It has dual wall construction in that there's 2 wall systems on the outside walls of this building. The 12-inch masonry walls, much like you're looking at here on this wall. And in between that and the face brick on the outside of the building is a 4-inch cavity. And there's 2 inches of insulation in that cavity, plus a 2-inch air pocket. And that creates the insulation that makes the walls energy efficient and watertight. Plunkett Racich Architects out of Milwaukee. One of their main focuses in their architectural firm is schoolhouse construction, and so they've been an architect for a number of years.
The fans, we're in the gym to move air, the heated air that's already in the gym, to move it around. There's 120 pressure sodium lights fixtures in the gym, and they were 400 watt bulbs, and we changed it to 360 watt bulbs, so minus 40 times 120, that's a lot of wattage that we saved. Another thing, we went in the commons, we also put ceiling fans in the commons to help move the hot air that all the lights generate and move that air, so it went through more of the building. A lot of heat that comes off these lights, and the fans really move the air around. 266,000. So quite a few square foot, and again, the architect takes that into consideration. The climate that we have in this area, that's why we have 6 boilers.
It's got high efficiency boilers in it, the dual wall construction on the outside walls and the insulation in the roof deck, dual glazed windows. All of those things help make the building energy efficient.
These can heat up about 130 houses. And there's 2 chimneys and 3 boilers to each chimney. Again, for the airflow. 4 water pumps, and they're divided into 2 zones. As these doors open up, more cold air is coming in, but that's trying to keep it warm because those are outside open. Now these 2 units will kick in, and because of the cold air rushing in, they'll try to heat up the air so that the climate, you're not in the commons or down the hallways feeling this cold air. And so that's why, you know, there's design, there's reasons why architects put the units where they are. 2 air handler units. Here is where all the air filters are. This unit here takes about 20 filters. You know, up here is the fresh air intake plenum, and behind it is the mixed air plenum. It's the biggest unit in the building. This whole wall is the air handler 5. So again, you got a monster wall of filters, and there's a lot of plenum or ductwork.
And there were a number of conceptual drawings or designs for this building. The goal to maximize sunlight into the classroom, to create a building that was less institutional and had some softer features to it, more warm, more friendly features to help fit into the needs of education today, and to give some flexibility into the building. The way the building is constructed, we constructed it in a way so that we could come back and take down many interior walls and reconstruct the building without getting into structural issues. So a lot of those features were built in.
It's basically distributed digital controls is what our system is. The computer here, lots of wires, goes to a main building panel that has all the microprocessors in it, and then from there you got the FLN, which is a network boxing that branches out to all the other equipment and devices that, you know, if it's univents, air handlers, lighting, stuff like that.
For sustainability, that's part of the ongoing maintenance and repair, maintaining the building over its lifetime. I think it's a well-constructed building.